Alright guys, today we're going to be looking at our essential question of how do we graph and analyze quadratic functions. In reality guys, we're not actually going to be graphing them today, we're actually just going to look at graphs and we're going to analyze those graphs. Remember, a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, or the form y equals a parentheses x plus h squared plus k. The first one is what we call standard form. The second one is what we call vertex form. Remember, a quadratic function is where the degree or power of your function is a 2. The exponent is a 2. So we're going to be looking at quadratic functions. Now, today's lesson has a lot of vocabulary, so let's take a look at some of the vocabulary we're going to be looking at today. The first is intercepts. An x-intercept is where the graph crosses the x-axis. A y-intercept is where the graph crosses the y-axis. The axis of symmetry is a vertical line through the vertex, and it's written x is equal to h. The domain are the x values of a graph, and we typically say the domain for quadratic functions is always all real numbers, or from negative infinity to positive infinity. The range are the y values of a graph. The intervals of increasing is where the section of the graph is increasing, and we read it from left to right. Intervals of decrease is where the graph is decreasing, and we read it from left to right. The vertex is either the highest or the lowest, so it's either or. So you're either going to have a maximum or a minimum for each of your parabolas. Wherever that max and min is, that's your vertex. Zeros, those are what we call the solutions or the roots. Now, if the graph crosses the x-axis, then those are what we call our real zeros. If the graph does not cross the x-axis, that doesn't mean that there aren't any zeros. That means that the zeros are simply imaginary. All right, let's take a look at one example. Let's say that this is my quadratic function. I notice that it is U-shaped, it's a parabola, and it has a vertex right here at this point, which is 2, 1. So that's my vertex at 2, 1. I notice that this is a valley, so this is not a maximum, it is a minimum. So the maximum doesn't exist, because if you notice, the quadratic function is going to keep on increasing up to the top. So it does have a minimum. The minimum value is technically 1. That's the lowest value that it goes to. Now that occurs at the point 2, 1, but the minimum value is y is equal to 1. The axis of symmetry, that is x is equal to h, or in this case, my vertex is hk, x is equal to 2. And so if I drew a line at x is equal to 2, I notice that that is the line of symmetry. I could split this graph in half. X-intercepts, well, there are none because my graph doesn't cross the x-axis. Now, that doesn't mean that I don't have any zeros. It just means that they are imaginary, that they're not real. They're imaginary. My domain, that's easy. It's just always all real numbers, or from negative infinity to positive infinity. The domain are your x's. The range is how low it goes to how high it goes. So the range, how low it goes to a y value of 1. And then up it goes on to infinity. So that's why it's from 1 to infinity. The y-intercept, it does cross the y-axis right here at this point at 5. So you can say it's at the point 0, 5, or you can just simply say at 5. The interval, y is equal to 5. The interval of increasing and decreasing, well, if I read my graph from left to right, I notice that my graph at first is decreasing. So it's decreasing from negative infinity to, where does it stop decreasing at? And we're going to look at the x value. The x value stops decreasing at 2. So from negative infinity to 2, it's decreasing. Then from 2 on to infinity, it's increasing. And that is all the characteristics for my graph. All right, let's look at one more. Take a look at this one. Notice my vertex is at negative 3, 6. And this is not a valley, it's a mountain, so this has a maximum. It doesn't have a min, so there's no min, but it has a maximum of 6, which occurs at negative 3, 6 at the point. So you could write it 6, or you could write y equals to 6. Zeros, let's look at the x-intercepts. My x-intercepts, it does cross the x-axis 2 places, at negative 1, 0 and at negative 5, 0. So my zeros are simply the x value. So my zeros are negative 1 and negative 5. Those are my two real zeros because they cross the x-axis at real numbers. My domain is still all real numbers, so I'm just going to write that negative infinity to infinity. My range, though, it keeps on going down, so its range is from negative infinity up until my maximum, which is my maximum is 6. My y-intercept, it does have a y-intercept right here at negative 8, so my y-intercept is at 0, negative 8. My x-intercepts are at negative 1, 0, and negative 5, 0, and my axis of symmetry, which I put that in the wrong spot, my axis of symmetry is x is equal to h, or in this case, x is equal to negative 3, because if I drew a vertical line there, then that's my line of symmetry. If I read the graph from left to right, my graph is first increasing, then decreasing. So it's increasing from negative infinity to, where does it stop increasing at? At this point, we're going to use the x value, so negative 3. So from negative infinity to negative 3, and then it's decreasing from negative 3 to infinity. And that's it for today's lesson, guys.